Hello guys, welcome back to my channel Vivek's Math Class. Today in this class I am going to solve some important questions of this chapter Arithmetic Progression which they may ask in board examination for 4 marks. So please watch the video till end and practice well. So before starting this class, if you are not subscribed this channel, please do subscribe, press the like button and share the link to all your friends. Eighth question. The first and the last terms of an arithmetic progression are 7 and 49 respectively. If sum of all its terms is 420, find its common difference. Here in this question, they have given the first and the last terms of an arithmetic progression and also the value of Sn, that is 420. Now we have to find the common difference. So let's solve this problem. Solution. Given first term of an arithmetic progression is 7, that is a is equal to 7. The last term of an arithmetic progression is 49, that is an is equal to 49, and the sum of all its terms is 420, that is Sn is equal to 420. Now we have to calculate the common difference, that is D. First, let us write the formula of nth term of an arithmetic progression, that is an is equal to a plus n minus 1 into D. Now let us substitute the value of a and an in this nth term formula. The value of an is 49. The value of a is 7 plus n minus 1 into D. Now n minus 1 into D is equal to, now let us shift this plus 7 to the LHS. It becomes minus 7, that is 49 minus 7. That is nothing but n minus 1 into D is equal to 49 minus 7 is 42. This is equation number 1. Now let us write the formula of sum of n terms of an arithmetic progression, that is Sn is equal to n by 2 into 2a plus n minus 1 into d. Here 2a plus n minus 1 into d, 2a plus n minus 1 into d can be written as, here 2a can be written as a plus a, and the remaining as it is. Now this a plus n minus 1 into d can be written as an, because an is nothing but a plus n minus 1 into d. So this can be written as an. Therefore Sn is equal to n by 2 into 2a plus n minus 1 into d can be written as a plus an. A plus an. That is Sn is equal to n by 2 into value of a is 7 plus value of an is 49. Now the value of Sn is 420. Substituting the value of Sn 420 is equal to n by 2 into 49 plus 7 is 56. Here 2 ones are 2 28s. That is 420 is equal to 28n. That is n is equal to 420 divided by 28. That is n is equal to 28 ones are 28, 140, 28 fives are 140. That is n is equal to 15. Now let us substitute the value of n in equation 1. Substituting the value of n in equation 1, we get equation 1 is n minus 1 into d is equal to 42. Now let us substitute the value of n as 15. That is 15 minus 1 into d is equal to 42. 15 minus 1 is 14. 14 into d is 14. D is equal to 42. Now d is equal to 42 divided by 14. That is d is equal to 14 ones are 14, 14 threes are 42. That is d is equal to 3. Here in this problem the common difference is 3. This is the required answer. 9th question. The sum of first 9 terms of an arithmetic progression is 162. The ratio of its 6th term to its 13th term is 1:2. Find the first and 15th term of the arithmetic progression. Here in this question they have given the value of the sum of first 9 terms of an arithmetic progression, and they have given the condition, that is the ratio of its 6th term to its 13th term is 1:2. Now we have to find the first term A and 15th term of the arithmetic progression. Let's solve this problem. Solution. Given, they have given sum of first 9 terms of an arithmetic progression, that is sum of first 9 terms is equal to 162, and they have given the ratio of 6th term to 13th term is 1:2. Now let us write the formula of sum of first 10 terms of an arithmetic progression, that is Sn is equal to n by 2 into 2a plus n minus 1 into d. Now let us substitute the value of n as 9 and Sn as 162. The value of Sn is 162 is equal to the value of n is 9. 9 by 2 into 2a plus n minus 1 into d. This is equation 1. Now we have the nth term of an arithmetic progression formula, an is equal to a plus n minus 1 into d. Here we have to calculate the 6th term and 13th term. That is 6th term is, let us substitute the value of n as 6 in this nth term. We get a plus n is equal to 6. 6 minus 1 is 5. 5 into d is 5d. And similarly, a13 is equal to a plus 13 minus 1 is 12 into d. In the question, they have given the condition. Condition is ratio of 6th term to 13th term, that is a is to 60, a6 is to a13 is equal to 1 is to 2. This can also be written as a6 divided by a13, which is equal to 1 divided by 2. Now let us substitute the value of a6. That is a6 is nothing but a plus 5d, and a13 is nothing but a plus 12 into d is equal to 1 into 2. Here we have to do cross multiplication. That is a plus 12 into d is equal to 2 into a plus 5d. That is a plus 12 into d is equal to 2 into a is 2a plus 2 into 5d is 10d. Now let us shift all the terms of the RHS to the LHS. We get a plus 12d plus 2a becomes minus 2a, and plus 10 into d becomes minus 10d, which is equal to 0. Here minus 2a plus a is minus a, and plus 12 into d minus 10d gives plus 2d, which is equal to 0. This can also be written as, shifting this minus a to the RHS, we get plus a, that is a is equal to 2d. Now let us substitute the value of a in equation 1. We get equation 1 is 162 is equal to 9 by 2 into 2a plus n minus 1 into d. This is the equation 1. Now we have to substitute the value of a in equation 1. That is 162 is equal to 9 by 2 into 2a plus n minus 1 into d. This is equation 1. Now let us substitute the value of a in this equation 1. 162 is equal to 9 by 2 into 2 into value of a is 2d, 2 into d plus the value of n is 9. 9 minus 1 is 8. 8 into d is 8d. It is 162 is equal to 9 by 2 into 2 into 2d is 4d plus 8d. 162 is equal to 9 by 2 into 12d. Adding 8d and 4d we get 12d. That is 2 ones are 2 6. That is 162 is equal to 9 into 6d. This, that is 162 is equal to 9 6 is 54. 54d. That is d is equal to 162 by 54. 54 dividing 162 by 54 we get 3. That is the value of d is 3. Now let us substitute the value of d in this. A is equal to 2d. That is A is equal to 2 into d. That is A is equal to 2 into value of d is 3. That is A is equal to 2 into 3 is 6. This is the first term. This is the common difference. Now we have to find the 15th term of the arithmetic progression. To find the 15th term, first we have to write the nth term formula. An is equal to a plus n minus 1 into d. That is n value is 15, a value is 6 plus n value is 15 minus 1 into d value is 3. That is a15 is equal to 6 plus 15 minus 1 is 14. 14 into 3 is 42. Adding 6 and 42 we get 48. This is the 15th term of the arithmetic progression. The first term is a, that is the value of a is 6 and the 15th term value is 48. These are the required answer. 10th question. The sum of first 7 terms of an arithmetic progression is 63 and the sum of its next 7 terms is 161. Find the 28th term of this arithmetic progression. Here in this question, they have given the sum of first 7 terms of an arithmetic progression value and the value of sum of its next 7 terms of an arithmetic progression. Now we have to find out the 28th term of this AP. Let's solve this problem. Solution. Given sum of first 7 terms is sum of first 7 terms, that is S7 is equal to 63 and they have also given sum of its next 7 terms, that is sum of next 7 terms is equal to 161. Here this is the sum of first 7 terms, that is 63. The sum of first 7 terms value is 63 and the sum of next 7 terms and the sum of next 7 terms value is 161. First 7 terms value is 63. Now therefore S14, sum of first 14 terms value is 63 plus 161. That is S14 is equal to 63 plus 161. 3 plus 1 is 4. 16 plus 6 is 224. That is S14 is equal to 224. So we have the sum of first n terms value. Sn is equal to n by 2 into 2a plus n minus 1 into d. First, let us substitute the sum of first 7 terms value. That is, here n is equal to 7 and S7 is equal to 63. Let us substitute these values in this sum of Sn value Sn formula. That is, S7 is equal to 7 by 2 into 2a plus n value is 7 minus 1 into d. The value of S7 is 63 is equal to 7 by 2 into 2a plus 7 minus 1 is 6. 6 into 2 is 6d. This can also be written as 7 by 2 into, here 2 can be taken out as common, and the remaining term is a plus 3d. 2 get cancelled, and 63 is equal to 7 into a plus 3d. Here 7 and a plus 3d are connected with multiplication sign. When you shift this 7 to the LHS, it will goes to denominator. So a plus 3d is equal to 63 by 7. That is, a plus 3d is equal to 7 ones are 7 nines are. A plus 3d is equal to 9. This is equation number 1. Similarly, we have to calculate sum of first 14 terms of an arithmetic progression. Similarly, we have to write the formula of Sn value, n by 2 into 2a plus n minus 1 into d. Here we have to substitute n as 14 and S14 value is 224. Now let us substitute these values in this Sn value, Sn formula. That is, yes, the value of n is 14 is equal to 14 by 2 into 2a plus n minus 1 is 14 minus 1 into d. That is, the value of S14 is 224 is equal to 14 by 2 is 7 into 2a plus 14 minus 1 is 13 into d. Here 7 and 2a plus 13d are connected with multiplication sign. When you shift this 7 to the LHS, it goes to the denominator. That is, 2a plus 13d is equal to 224 by 7. That is, 2a plus 13d is equal to 7 3 is 21, 14, 7 2 is 14. That is, 2a is equal to 32. This is equation number 2. Now, multiplying equation 1 by 2, we get equation 1 is a plus 3d is equal to 9. Multiplying 2 throughout the equation, we get 2a plus 6d is equal to 18, and equation 2 is 2a plus 13d is equal to 32. Plus becomes minus, plus becomes minus, plus becomes minus. Plus 2a minus 2a get cancelled, and 6d minus 13d is minus 7d is equal to minus 32 plus 18. We get minus 14 as the answer. Here minus minus get cancelled, and the value of d is 14 by 7, that is d is equal to 2. And now we have to calculate the value of first term. So substituting the value of d in equation 1, we get equation 1 is a plus 3d is equal to 9. A plus 3d is equal to 9. So a plus 3 into value of d is 2 is equal to 9. That is a plus 3 into 2 is 6 is equal to 9. That is a is equal to 9. Let us shift this plus 6 to the RHS. It becomes minus 6. That is a is equal to 9 minus 6 is 3. This is the first term. Now we have to calculate the 28th term. That is n is equal to 28. A is equal to 3. D is equal to 2. We have to calculate A 28. So the formula to find out the nth term of an arithmetic progression is given by an is equal to a plus n minus 1 into d. That is a 28 is equal to value of a is 3 plus value of n is 28 minus 1 into value of d is 2. That is 3 plus 28 minus 1 is 27. 27 into 2 is 54. That is 28th term is 54 plus 3 is 57. This is the 28th term.